we're going to start with this. So first of all, I will just go ahead and create a new 3D scene in this case, okay? And I will just call it main. Then I will just save it as we have already done it 1,000 times. And let's start talking about the grid map, okay? Let's look for it, grid map. As you can see, even in the description it says node for 3D tile based maps. And it's quite similar to what we have seen about 2D tile maps. So let's go ahead and add it. As you can see now, as soon as we add it, we do have like these quadrants over here, these cells, let's say. So for this, as here we have this message, we have to give this a mesh library. What is a mesh library? Well, it's something that we assign over here that we can load. But for this, we need a mesh library resource. And it's not as in collision shapes that we press it over here and we have the options, because, well, we do kind of have here our mesh library, but as you can see, it's completely empty. I cannot draw anything. I just have those lines over there, which don't do much. Okay. So what I need to do, first of all, let's delete that resource. And we will need to create this resource from scratch. And how this is done is that you create a brand new sim. That I will create as a new 3D sim, okay? And I will just call exactly like this, mesh library. So let's rename it to mesh library. Okay.
This video is part of my full 10-hour Godot course just released in mid-May 2025. Every day, new students are joining and leveling up their Godot skills, and you can too. Want to learn more? Click in the description down below.
As simple as that. Now we need to save this sim over here. And now if we go to the models, well, the player right now we are not going to be using it. I just want to use the objects themselves. Well, here we have like dozens of things, okay? So what we'll just do is left click on the first one and scroll down until the last one. Okay, I will hold down Shift, okay, and then left click again to select everything, and I will just drag and drop everything. Okay, it doesn't matter where exactly in the scene, okay, as long as they are in the scene, that is what we care about. So I will just drag and drop them, let's say over there. Once again, this doesn't matter. And now we do see our models. Now what we can also see is that they are all in the same place. Once again, if you want, you can go into each of these models and using the move tool reposition them. Okay, once again, this doesn't matter because the mesh library doesn't care about that. What the mesh library cares about are the models that we have loaded in. As you can see, when we import these things, what we have is, let's say, an instance of a scene as well. We have already worked with instances. I can use these terms now that you should be able to completely understand them. So whenever you import a Godot model, at least in this way, what Godot does is that they import it, okay, it is imported as a scene. So what this means is that we can click here to go to the scene, but here it says is scene arrow.glb was automatically imported so it can be modified. To make changes to it, a new inherited scene can be created. I won't really talk much about inherited scenes, all that, it doesn't really matter, but if you want to open it anyway, in this case, the only thing that we have here is the node 3D, and this is the mesh. As you can see, this is a mesh 3D, which by the way, is just another type of node, mesh instance 3D. And this is the image itself, let's say the model, and this is just a root node. Okay, this is how Godot imports it. Okay, once again, this is just for you to understand how the 3D workflow works. So now that we do have it like this, the only thing that we have to do is to go to scene, export as mesh library. Okay, I will just save it right here on my resources folder, and I will call this one just my mesh library. Okay, exactly like this. I will press we have these options also, merge with existing and apply mesh instance transforms. Right now we don't really want to check them out, it's not necessary. Let's press save, and now if we go to the file system, what you will indeed find is that we have a new file, mesh library.tres. Okay, so we can drag and drop this resource, and voila, we have our meshes. Okay, so this is also, by the way, quite similar to how a 2D tile map works. If you wanted to create a level in 2D, it's pretty similar, just that setting the tile map up is even simpler than in 3D because you just use images, you don't have to create a new mesh library or anything like that. But now the only thing that is left is to just start drawing our level, but we will also see that there are some things that we have to understand first. So for example, let me click here on the block of grass. And now, as you can see here, we have some painting tools such as the selection, eraser, the brush, okay, to pick a certain type of these ones. So for example, I can paint here with this. As you can see now, I have my block of grass. So here we have it, here we have them. Now if I want to pick, let's say that I am on the key and I'm also painting these keys around, and I want to quickly go and pick the block of grass, well, I press here and select it, and it's automatically selected. So I can go back to the paint tool and continue painting. Now, all these things have their shortcuts, okay? So you can use them. I don't really have them in mind because they are just too much. But well, just for you to know that. And we can also make this a little bit smaller. Now, in order to navigate the 3D scene, what we want to do, let's say here I want to design my level. Well, how do I move the camera and everything? So first of all, when you're holding down the right click, okay, you can pan the camera around. So I'm right now holding my right click and I'm moving the mouse. Okay, so here I can move the camera around. I can rotate it. Now, how do I move? I have to be holding down the right click and WASD to move around, okay? And also at the same time, you can rotate the camera to move around. You can also be holding down shift as if you were sprinting in Minecraft or in other games where sprinting is allowed, and you can move even faster. Right now I am sprinting and right now I am not. As you can see, it's pretty obvious the difference between sprinting and not sprinting. Okay, so that is the basic navigation, okay, in 3D. And also with while holding right click, sorry, you don't have to hold a right click. Just with your mouse, you increase or decrease the zoom, okay, with your mouse wheel, okay? So let's say, okay, I'm moving around, whatever, okay? I want more zoom over here, okay? There, how it, and as you can see, I am kind of combining everything in one piece. So with this, we have like a pretty interesting setup, okay? But there are still some things that we have to understand. So let's say that we have this block of grass over here, and well, and until right now, everything seems correct. We do have some separation here in between them, but it was the idea of these ones to be separated. This is how they were configured. And so you can see here, we can in reality start painting around. Okay, let's say we have some platforms there. We also have, if you don't press down the right click, what's going to happen is that you will rotate, as you can see, this mesh, or even you will go to erase if you press W. So this is because here we have some shortcuts that, as you can see, also correspond to W, A, S, and D. This is A, this is S, this is D, and this is W. So this is not pretty well mapped, at least for me. You can still change the shortcuts, but anyway, if this happens to you, just start pressing A, S, and D until the model looks correct. Okay, there we have it. And there it is again, okay? Now, what happens if we want to increase the y-axis of our platforms, okay? So what we do here, we have a floor value, change grid floor. So we can increase it by 1, for example, and now we are in floor 2, okay? So here we can continue painting things around as we want. Now, this is not completely bad, but what we can do is go to cell, and here you can see you have this cell size. These are the cells in reality. Okay, so you can increase this size, decrease it, whatever you want to do. But in this case, the y-axis has a problem because, at least for this setup, okay, and for the effect that I want, what I'll just do is that I will make this size be 1, okay, so that everything is stick together. How did I know it was 1? Just because I was trying out values. So if I make this 2 again, and I decrease this, okay, with the left mouse click and sliding to the left, okay, what you can see is that, yes, the value is around 1, so 1 is a value that will work. Okay, so as you can see, it's mostly like perfectly aligned, mathematically aligned. Okay, this is just a matter of trying. And once again, the sizes of the X and the Z look correct, at least for this setup and for what we want. If you said, okay, I want this to be like completely in the same position as this is, well, you may need to decrease the X size a little bit, maybe to something like 1.5. Okay, in both axes in reality, because if not, here as you can see, it is not in the same place, so 1.5. Everything will kind of break, or well, it doesn't break, but it doesn't look too correct. Now you have to just leave more space in behind, okay? So you can do this these things, for example, okay, that you weren't able to do before. So well, you can start to see where this is going. And now that, well, we have like a dozen of meshes over there, we can use the erase tool and just delete everything. Once again, remember that we have floors, so we have to go here. I am in floor 0 right now, so we have to delete everything like this. And now let's go to floor 1 and delete everything. Okay, there we go. So also, let me show you some of these tools that could be useful. Exactly this selection tool. So for example, let me once again just paint here a couple of grass over here. Okay, there we have them. Okay. And what we can now do, as you can see here, we have a small error, but this is because we have meshes that are stuck on top of each other. That's why I told you that I don't like to change this x-axis, at least with this current setup. Sorry, this was 2. Okay, I prefer much more to just have those spaces. Okay, there will be like a better way to, because basically these platforms that I imported are not meant to be used this way. These are platforms. Okay, this is not to create like a whole ground or something like that, because we have this problem. Okay, but this is not the problem of the setup. This is just because the model has rounded edges. Okay, so it's the model. Actually, in the asset pack that I downloaded, there were more models to do something like what we wanted to do here, to create a square or a rectangle, but I didn't import it. Yeah, that's all. So for the select tool, you can indeed select. Let's say that we wanted to select that. Okay, and then for example, what we would be able to do is to move them. So move, and now as you can see, I can move this piece around. I could also duplicate it. Okay, so now I have like a custom brush, or well, not a custom brush, but I was able to just duplicate it and put it wherever I wanted. What else do we have? We have move. Well, we also have fill. So let's say that I select this area and I select fill. It's going to be filled in with the type of mesh that I have selected. We also have delete, which is basically exactly that. So let me select this portion and delete. How to add collisions to these tiles? Because what currently happens is that these are just, let's say, meshes. So sprites, okay, would be the equivalent to 2D. And they have no collision, okay, no nothing. They are just shapes over there. So what would happen is that, for example, let me add here a rigid body 3D. I'm just going to do a super quick test, and also you're going to be understanding some things. So if I have the ball, what I can do, remember that if we wanted to add a ball in 2D, well, we would have maybe an area, a rigid body, a character body, well, whatever we would need to use. Then we would have a collision shape. So that's the same thing. This is also the equivalent, collision shape 3D. And also let me select the ball again. Instead of adding a sprite, we are going to be adding a mesh instance. Okay. We have the same warning as before, that we must provide the shape in the collision shape. And for the mesh instance, we have some pre-made shapes. These are also called primitive shapes, such as spheres, cylinders, capsules, boxes, etc. So for a ball, I'm going to be using just a sphere. Okay. We can also see it once again navigating. So I will hold down right click, press W, A, S, and D, and I will also just move around my mouse while holding down right click. And here it is. Okay. So what I'm going to do is grab the ball and move it up. So here we can see it. Okay. And I will add a collision to it. So this is a sphere. So let's also add a sphere to it. There we have it. Okay. As you can see, it matches perfectly the size. That's correct. So here about the collision, now going back to it. Why is it passing through it? Okay, because these tiles, these meshes don't have any collision, okay? So what we need to do is to go to our mesh library and add this collision. So how exactly? The first thing, which is pretty chaotic, I wish there was like an intuitive way to do it, but what we have to do is that we need to add these colliders. Now, Godot provides a super easy way to do it, but first you have to right click on this and make them local. Okay, so let's make all these things local. So right click, make local. This will just delete the inheritance basically, and this will just be a local object. So let's do it like this. It's not that much, but anyway. I believe there could be a way to improve this workflow, but personally I've always worked like this and I have not been able to find a better solution. So if there is any, I will try to update it so that you also know about it, but right now I have not been able to see it. So In reality, here there are some objects that then I am not going to be using right here, but it doesn't matter. So what we have to now do is that, well, now we have it like everything like this. Some of them have other objects inside of them, such as these two animation players. But anyway, we are not going to be paying attention to that. So here, what we have are the meshes. So for example, let me move this one. This is the arrow itself. So this one is not an object I want to add collision to. This would be like a decoration, and I don't really want to add collisions to my decorations. To the object that I want to add collisions, let's actually try to move them around so that we can see them. I will turn on snapping, okay, so that I can kind of move these things around. We also have another decoration, which is the barrel, and we start to have these blocks, okay. So for all these blocks, okay, what I'm gonna be doing, I will first select the meshes. So I will press on this one. I will hold down Control and select this block grass, this one, sorry, this one not, so I will click it again to unselect it. Okay, I will select all these blocks of grass, and I believe they are all. If not, we can still go back and fix this. And what we need to do is to now press here on mesh, create a collision shape. Now here, this is a way to quickly add collisions, okay? And you have many ways. First of all, the collision shape types, okay, we're going to discuss that in a second. And then you have the collision shape replacement. It can either be a sibling or a static body child. In reality, for this case, we also want to add a static body. We have already discussed why static body and not just a collision itself or whatever, because this will just create a collision shape, but we can't really use a collision shape if it's not attached to a collision object. So in this case, what we want to do is to create it with a static body child, as a static body child. And here in the collision shape type, well, I'm going to actually discuss this in a second with you, but the one that you're going to select right now, once again, just follow along for this one. I will show you in a second why single convex, but just select it and press create. Okay, now we have all these collision shapes automatically created, as you can see, for all these objects. Okay, so all these objects that we have selected now have a static body and collision shape. So pretty interesting way of doing it, okay, quite simply. So what we must do now, if we do try to play again, the mesh library should not have been updated yet. Okay, so we don't have these collisions. So what we need to do is to go to scene, export as mesh library. Sometimes Godot drops errors when you try to override these mesh libraries for some reason. So what I will just try to do is to replace it over here, and if you get an error or if I get an error, well, we will have to save it as a new file. So now that we have it, what we should maybe try to do is to play the scene, and if collisions, well, we do have the collisions there with no errors, so amazing. Once again, if you have some issues with this, save it as a new file. So still export it as mesh library, but save it here as a new file. So call it mesh library 2 or something like that. And when you do that, you have to go to the GridMap and change the mesh library to use that new mesh library that you've just created. So now this is how we set up collisions. This is super important for when we actually set up the player, because we don't want the player from falling off of the platforms. So right now we'll just leave this poll. It was just an example, and also at the same time for you to learn what a rigid body is. So here we do have a pretty interesting setup. The last thing that I'm gonna talk about are basically collision shapes 3D. So this is a page. Oops. So here is, sorry, the documentation. You will also have a link in this lesson resources. So you have collision shapes 3D, okay? So first of all, you have primitive collision shapes. I already mentioned, I believe, primitive shapes. These are pre-made shapes, basically. So these are shapes that we all know about: geometrical shapes, box, spheres, capsules, cylinders, etc. But then you have convex collision shapes, and these are used to represent shapes of more complexity. With these ones, you can just represent boxes, spheres, capsules, cylinders, etc. With these ones, you can actually represent any object's shape. In this case, for example, we do have pretty basic meshes. We don't have too complex ones. But for example, if we take a look at the one that was some kind of slope, this one, okay, this is not a box, okay, this is a slope. So you can see here also how the collision is formed.
Okay, we couldn't have done this with the box at all. We maybe could have done it if we rotated the shape or whatever, but it's not the idea to do all that work, because imagine if then we had a dozen of these assets, it would be quite annoying to always have to do it. So those are the two main types of collision shapes, but they also have like their types inside of them. So primitive collision shapes are box, spheres, capsules, and cylinders. And then we also have convex collision shapes. And we have different types, which are the ones that we have seen when we wanted to do this trick, okay? So we have tree mesh, single convex, simplified convex, multiple convex, okay? So these are all explained over here. I don't want to spend like a lot of time explaining it because it's super well explained here, but just for you to know, single convex, okay, they use different types of algorithms. We don't care about that. So this one, the key thing is that it only generates a single shape, okay? So it's pretty good for the performance, and it's very good for what we have when we have small and simple objects, okay? As the ones that we don't have like pretty big things or things that have a complex shape, okay? Then we have, and by the way, single convex collision, we have it here, single convex, okay? So it's this one. That's why we actually use the single convex. Then we have multiple convex, which is very similar, but it generates multiple shapes. We don't have single shapes, we have multiple ones. So this is more accurate for concave objects, okay? But it consumes more performance. So this is ideal for medium complexity objects. Okay, once again, we don't have that, but just for you to know that. And we have concave or tree mesh collision shapes. So we have already covered single convex, which is this one, and we have already covered multiple convex, okay, which is this one. We now have simplified convex and tree mesh. So we have concave or tree mesh collision shapes. These are the ones that are the most complex for most complex shapes, but also are the most accurate, okay, but are the ones that take the most performance. So here we have a tree mesh, okay, so it's basically this one. So basically it creates a static body containing a concave shape matching the mesh geometry. So it will match this geometry 100%. If you check here, well, here we don't have that complex objects, but for example here, if you check this part over here, it is not 100% perfect. It doesn't match the geometry 100%. But once again, who really cares about this part over here? In this case, we don't care about that, but there could be some games, some models that in which we do care about that collision specifically. So just for you to know that. And well, this is the same thing for both. We can either create it as a static body, as we have done over here, or also as a sibling. Okay, so but in reality, they work in the exact same way. And we also have a last one that is not really explained. There, at least I didn't find it anywhere, but it's pretty simple to understand. Which is simplified convex. It's as convex, so we'll just generate one shape for everything, but it even saves more resources. I don't really like it very much because here we do see some things that are not correct. So here's quite complicated to see because of the background. But let's try to do it over here. Here, like the geometry is super bad. Okay, so for example here, check how the player would be able to, the collision would not actually be good enough. So check here how all these parts are not included. So this would be like for something that you don't really want to have a lot of collision, or you are really tight in terms of power in the PC or whatever. So really simplified, I don't see it working. So that's basically why. Let me delete that static body again and just make it again. So collision shape, static body child, single convex, okay? And here we have it. And in reality, if you really want to see the other ones, we can indeed do it. Now that you understand each of them, so we have used single and simplified. We have tree mesh, which as you can see, matches mostly like 100% the shape of everything, okay? Or it tries to match it as much as possible. And lastly, we have the last one, which is multiple convex, okay? So once again, it tries to match the shape of it 100%. You can still see some stuff over here that maybe is not that correct, but well, then when we actually play the game, maybe Godot optimizes everything and it works flawlessly. But well, once again, this is just for you to know some basic information about these types of colliders, okay? So, but as we have already mentioned, let's only talk about single convex in this case because it is what we need. Hi there and welcome to a new lesson in which with everything that we have learned, what I want you to do is to design, okay, a level. Now, don't make this the definitive level with the coins, the flags, keys, obstacles, etc. because in reality then we'll have to start from scratch. What I just want you to do is to do something very simple, okay? And basically that the player can move around, jump a little bit, and basically that you can also use the floors to create height in your level, okay? So with that is going to be more than enough. So right now, pause the video, design your level. Once again, I would only really use like these blocks until right now, no decoration, no anything. And in reality, with just maybe one type of these blocks, maybe with this one, you can create the platforms. Once again, don't spend that much time. You will then have to delete everything and start from scratch, or at least have to design it again. This is just a prototype. So here I will show you how I have designed mine. Once again, super simple. So first of all, using the tools that we have learned, how do we delete all this? What we're going to be doing is to use the select tool, okay? Or selection tool in reality. Let's select everything. And now with this one, delete, okay? Everything is gone. Let's start in floor 0 in reality, which will be, I believe, the best choice because it starts right at the origin of the world, where, as you can see, every single line intersects with each other. So let's start somewhere here. It doesn't really matter where you started, okay, by the way, don't worry. So let's select, yes, with this block, I think we're going to go just fine. So I will just move around a little bit. I will create here a 2x2 platform, for example. Once again, your level doesn't have to be the same as mine. So something like that, maybe. I will create a simple jump over here, another jump, maybe a trickier one over here. Over here, another one here, okay, and another one over there, and lastly, well, this would be like the aim, okay, something like that. I believe it works all right. So this is the level, okay, that I've designed. Don't worry about the camera or anything like that. Then in the next lesson, we're going to be adjusting all this. But well, at least with this, we do have a place in which the player can spawn, like right here. And well, then the player can jump in all these platforms and will reach the end of the level, okay? So I hope that you are able to follow along with all this, and I will see you in the next one. Hi there and welcome to a new lesson in which we are gonna be adding, okay, all these objects, all these obstacles inside of our level. Remember that if in reality you want to add even more elements, you can do it. To quickly go to another scene, you can press Ctrl-Shift-O. This will open up this window, select scene. So you can either look for it or just type it. So main and press enter, for example. Okay, so here we are. And here we have to go to 3D mode and start positioning this obstacle. Once again, don't make this the definite level because then we're gonna actually build the final level, okay? So let's first of all create a new container for our obstacles. So I'm gonna call it obstacles container. And also, as here we have two containers, what I could do is to create another container for the container. Okay, so I could call this one containers, and I could just take both and put them over there. For example, let's put here this one just to have everything organized. Okay, and then inside of this obstacles container, I could add the actual obstacles. And here you can see how, thanks to the system that we have, the coins are going to still work well. Why? Because they directly call the canvas layer, so it doesn't matter where these coins are, they will always be able to find the canvas layer. Because previously what we had to do, if we didn't use this, was to do get parent.getParent.getNode canvas layer. Now what we have to do is get parent, getNode. Okay. So once again, now with this logic, we can execute the game and it will still work. You may not see here the advantage of this because of course it is a pretty small game, so we don't really have a lot of problem with this. It's just modifying one line of code. But trust me that in a game in which you have dozens of scripts, dozens of nodes, there you will see a difference, okay? Because you will have to modify maybe 100 lines and you won't like that. So now let's grab our obstacles container and instantiate the obstacles. So let me instantiate one saw. I will now go back to the obstacles container. With this button, one spike of this one spikes, the normal ones. And lastly, the ones that were a large block. I don't remember the name, to be honest. This one, spike blocks wide. Okay, just one of them for each one. So once again, using object snapping, let's grab the saw and let's put it here, for example. Once again, thanks to the snap, how we have it configured, we can perfectly position it. But if you can't, make sure to play around with the values. So transform, configure snap, and play around with this value. Let's grab here the spikes. So let's position these spikes actually on top of a platform. So maybe here. Once again, here we do have a problem because we want to position them on the floor, basically on the ground. And as you can see, with the current setup, we can't. So what we could do is do configure snap and try another value. So maybe 0.5. There it is. Usually when you can't make an object fit, you have to decrease the snap, okay? So just for you to take into account that. So here we have it, and we can actually use the same snap for the spikes in reality. The thing is that we're gonna move in smaller increments, okay, rather than bigger increments, but it's the same thing. So here we have it. Let's put another one, I don't know, maybe here in the middle of these two. Maybe something like that. Okay, yeah. So now we can play, and whenever we collide with them, we will be reset. So if I collide with this saw, game over, restart. Okay, with this spike. Okay, right now this spike does not work, but I believe it's because it doesn't have the script. Yes, I know why. And this one either has the script, so this is pretty weird because here they do have it. I believe this is an error of Godot, so let's go to project, reload current project, and give it a second. So let's wait a second. And now they do have the scripts, but they don't have the signals. I think, no, they don't have the signals now, so maybe they were not connected correctly or something happened. If signals continue to break, you can still connect them manually via the code. So I will show you that in case you want to know also, because it could be useful. So what you could do is, we are inside of the area, so we could directly call the body entered signal dot connect, and we can connect it to on body entered. Okay, as simple as that. And we don't care about what is here in the inspector, because here, yes, as the script was not attached correctly, also here this connection broke down, so better to just do it via code. So yes, now this should work properly. Here we are. Let's collide with this. There we go. Then we have these spikes. There we go. And lastly, we have the other spikes. So let's try to collide with it. Okay, there we go. And okay, this would be for detecting the collisions with the obstacles. Lastly, what I want to add is that, once again, these obstacles seem a little bit too static for me. So what I want to do is to grab their Z rotation and increase it over time. Once again, you can randomize the speed if either they rotate backwards or forward. It doesn't really matter. So quite similarly, in this case, what I'm gonna do is that some objects I want them to rotate and some others I don't. Because the spikes, they wouldn't make any sense to be rotated. But maybe the saw and these spikes would make sense to rotate them. So how do we go about it? One way to do it is to directly use the export annotation and say, okay, can rotate, and make it a bool. Okay. And then, okay, we can also directly declare a constant. Okay, so rotation speed, and make this a float and 200.0, for example. And once again, then use the process. Now, the order here is ready, and then it comes process, so it has to be below it, process. And here we do the same thing, but we also rotate if we also check if we can rotate. If so, we take rotation decrease dot z plus equals delta. Actually, let's do just to I like it more rotation times delta rather than delta by rotation, but it's the same thing. And with this, it is it. So spikes, I will actually make can rotate equals to true. Okay, initially. So I will just disable it in the spikes. This is just because I have more obstacles that can rotate that can't. That's why I will do it this way. But now you're gonna see these obstacles rotating around. So this really gives the level some level of dynamism. And also more difficult now because this guy over here is moving around. So we really have to be careful. Okay, there we go. And here we have passed this very simple level. Hi there and welcome to a new video. In this one, okay, we're gonna be designing the final level, okay, for our game. Now, a couple of things for you to know this. Remember, we how to use the grid map to draw the different things, but remember not to include, for example, the coins and the obstacles with them. We already explained this, that we should manage them differently, but do use a snap to position these objects such as the coins and the obstacles. Make your game as big as possible, as big as you want, sorry. Add as many coins as you want, as many stuff in general as you want. Just bear something in mind, our canvas layer currently just supports 1-digit numbers. So if we go to the coins panel and we go to the label and we have collected 10 coins, well, then the UI is gonna kind of break, so you may have to increase this size a little bit, okay, if you want to do it. I will just do it, maybe something like that. So there it is. And what else can I tell you? And also, this is what I wanted to tell you. If you make your game bigger, probably you may need to also increase the death zone collision shape size, okay, so that it covers your level. So don't just take some time. I will still design my gaming level. I want to go super crazy, but I will try to create something interesting at least, okay? So pause the video right now, take your time, and then we're gonna continue together. So here I am again. I will design my level here live with you just for you to know how I think about this. But once again, if you ever feel bored or whatever, you can just, if you have your level finished and your dead zone with the correct size, you can just go ahead and skip to the next lesson. If that's the case, see you in the next one. If not, here we go again. So in this case, what I like to do whenever I want to design something from scratch is literally this. Use the selection tool, grab everything, and remove everything. Okay, oh, here it didn't work because of the floor, I believe. Remove, there we go, and everything, right? So all these coins, spikes, whatever, directly from scratch, okay? I will just remember the orientation for the level so that we know how to do crazy stuff, but it should be from that position. So let's grab here the grid map. And let's grab here, let me make this a little bit bigger. So first of all, I want my player to start off in a surface. So let me use the paint tool over here and let me use these ones. What I will do is that I will put one grass over there and I will move the player towards it. So I will use snap for this. I will change the snap in this case because it's too small and it's driving me crazy. I will make it 1. There we go. And now let's start thinking about it. So first of all, let's give the player some easy jumps, okay? So first of all, start off with 3 easy jumps. Then let's give it some space in behind and make it more complicated. So once again, maybe something like that, or even let's start adding some difficulty to this. So there, the player's gonna have another jump to do. But for example, let's see if adding a slope is worth it or not.
I believe this is the rotation that we need. No, it isn't. Using the shortcuts also, maybe we can take advantage of this. No, this one it isn't. Let's see. Rotation is always my weak side, as you can see. But well, let's see which is the correct angle for all this. But anyway, forget about it. Let's use another one. It's driving me crazy. There we go. Perfect. So let's use here another one to create more complicated jumps. It doesn't also have to be linear, okay? So let's also try to make it kind of walk around. So let's create here another one. No, maybe that one doesn't really look good. We can also add some decorations if you wanted to. You can even make them bigger. I didn't show you that, but anyway, I will show it to you in the next lesson just in case you want that. But for now, what I'm gonna be doing is grabbing this one again, and let's make here, or actually this one that is a little bit smaller, maybe something like this. I don't know if the player has enough force to jump to this one, so I will just make them a little bit closer to each other. So something like that. Okay. Then we'll also put obstacles in behind them or in between them. I will also delete these ones that I have over here. So these ones are in floor 0 probably. Okay, sounds good. Let's go back here with shift so that I can sprint. Let's now do something like this. So another one, and then let's put another block of grass over here. And what else can we do? Let me think. Let's just do let's do more jumps with these ones now. Okay, maybe something like that. Or we could actually increase the floor, right? Just to give it some variety, if not everything's gonna be the same thing. So let's go to floor 3 now. Let me grab now this one. Let me grab now this one, sorry, this one. Okay, there we go, a diagonal jump. I'll actually implement a couple of diagonal jumps, but I actually want to increase the floor as I go. So I will go to floor 4. Where's the paint tool? Over there. Let's increase the floor again. Okay, there we go. Yes, it looks pretty good, at least for me. And then right over here, let's just make 3 more jumps, and then the game is over right over here. Okay. So yes, I believe that with this we do have a more than an interesting level actually. This is enough. Now let's go to the coins. Okay, there we go. So let's leave them up and let's start positioning them. So let's move them back. Okay, yes, I believe they look good. Yeah. So let's put 1 coin there. Let me duplicate it with Control D. I will put the other one right there. Yes. Let's do it like this and lift it up a little bit. Yes, just as we also include coins in the middle of some jumps. What else can we do right now? We have 3 coins. We're gonna then add some obstacles. But now let's also add coins in these other positions. We can also rotate these guys with the snap. Over here. Oh, I rotated it wrong here. Right there. Okay, there it is. Let's add another one. Over there or here in reality, like in the middle of the jump. I don't know. No, I don't think the player can jump that high, so let's lower it just in case. And let's add the last coin, maybe this place over here. Let's see if we can add it exactly on top of this platform, but I think that we can. Over here and over here. Yes, good. The magic of being able to snap things. Yes, this is mathematically centered, so perfect. And lastly, the last coin, so I will just have 7 coins. You can have more if you want. I don't want to just oversaturate the player with 1 coin in every single jump. Okay, yes, there it is. And then I will also go ahead and add the flag here at the end, but what happens with the flag is that it is right now too small. So probably that the floor has to be increased, and we'll have to rotate, so it should be in the, nope. It should be over here, okay? But why is it like that? Well, anyway, and then we have to make it bigger, okay? Then we're gonna go to do that in the next lesson. Let's collapse this. That's why I like using containers. You can clean up the hierarchy a lot, and now with obstacles. To do this, what I would firstly do is to instantiate one of each type. So 1 spike. You can even drag and drop them if you want from the hierarchy, but we don't have that many, so it's pretty still easy. So let's start off with the easiest one to dodge, which is a spike, sorry, a saw. Over here, okay, let's add some spikes. Okay. Yes, with these ones I have to decrease the snap, so to 0.5, I believe it was that I needed. Even less, really. 0.25. Okay, so we can, with this, as you can see, position it mostly wherever we want it. If we even wanted to position it like in an edge, mathematically, we would have to even play around more, but you know, I don't care about that. Something like that, it is still pretty good. Or I will put it maybe here. I like it more, I believe. Yeah. So then for these spikes, let's leave the player some space to breathe. And over here, let's put another one. Yeah, yes, because I don't want, once again, to all the time be putting there obstacles and obstacles, because if not, for the player it's gonna be too difficult, and I don't really want that. I don't really think if here, the player is not gonna be able to dodge that, so maybe I have to put it over here. Maybe we have to increase the jump force or whatever. Once again, these are things that you can adjust as the game is being played. Yeah, but I don't think the player can go past this, right? So let's actually save these ones for another situation. So for example, for when we are jumping here, I believe here is a much better situation. So here it is, I believe. Let's move it back. Okay, yes, and let's lower it just a little. Yeah, I like it, maybe. Something like that. What else can we do? Right here we have too few obstacles, so let's add a couple of them. Let's add a couple of spikes, so I will duplicate it and put it maybe, I don't know, somewhere here. Maybe here on this edge. Okay, there it is. Then grab this saw and I will put it on the contrary side, so it's gonna be here and then here. Yeah, I like it. Okay, then the player will jump here, then you're gonna have this obstacle. Okay, then let's grab this other obstacle and duplicate it, and I'm gonna move it right here. Let's also increase the snap, because if not, it's more complicated to check if they are actually centered. So maybe with 1, I believe it's gonna be good. Yes, but now this is not centered because we have 0.25. This should be 8. And now we should be able to center it. There we go. We have this coin. You know what? This coin, let's move it to the next one. You can, of course, adjust all these things as you design your level. Yeah, it looks pretty well, I believe. And what else can we do right now? Yes, I don't think that we need too many obstacles here. Maybe if we can add some spikes just to continue annoying the player a little bit. But the thing is where, because here if I add a spike here, they're gonna die. directly because they have no space. I could make them smaller, you know, but I don't think it's what we want there. So let's move them, let's say over here. But if I put, yes, I think here is a good place in reality. Yeah. Let me grab one of these ones again. Let me rotate it and grab it over here, over here. Okay, nice. Maybe something like this. Once again, I will have to test this to see if the player can pass through these things, or we need to make them bigger, smaller, or whatever. But as far as I have tested, the player should be able, okay? But then we're gonna see. So yes, we have this jump right here. We'll put this one here. And I will grab these spikes, and then what I will do, you know what? Let's do something complicated for the end of the game. Let's make this way bigger, maybe something like this. So the player can just land in one place specifically that we define. So something like that. Okay. And that maybe the player has this flag. Let's move it back. Okay, in reality it's not that bad, the size, but then we're gonna fix it. Let's remove it and let's paint it right here. And here let's put the last coin that the player has to collect in order to win the game. Okay, so let's duplicate this last coin. Let's move it here. Okay, and now let's play. Right now, remember, there is no win condition yet. We do have the possibility to lose. So we're gonna see. So let me disable the cursor here. And let's also maximize this. Okay. So let's play around. Here we have the first coin. Of course, we can adjust it as much as we want, but well, like this, at least we can play. Here, I have not collected this coin, so let's try to collect it. There we go. Let's wait. Oh, right now. Okay. Yes. Until right now, it feels pretty cool. It's not that complicated. I'm not a professional gamer or whatever. Okay. Yes, it looks perfect. Let's wait a second. Right now. Okay, and this jump is probably the most complicated one, but I don't think it's a big deal. I think that even maybe if you jump from the super edge, you are able to skip all these spikes, but whatever. And here, well, there should be the you win the game canvas or whatever it is. Hi there, and in this video I'm gonna show you how to make certain objects bigger, okay, inside of our grid map. Because for example, well, most of the objects look good, but for some reason, well, the flag is a little bit small, maybe. So what happens if we want to make the flag a little bit bigger, if certain grass block we want to make it bigger? How do we go about this? So it's actually pretty simple, fortunately. So what we're gonna be doing is the following. We are gonna have to open the, with Control Shift O, we can quickly open the scene. So let's look for the, how is this called? Mesh library. Yes, there we have it. Sorry, so many names, sometimes they can make me lose my mind. So let's go to the flag over here. Okay, so here we have the mesh. So what we have to do is to resize not the root node, but the mesh. Okay, because the mesh library exactly does that. It takes the mesh size, okay, not the size of this. This can be any size. What it's gonna take is the mesh transform. How can we validate it? If we go to scene, export as mesh library, we actually have this apply mesh instance transform. Okay, and merge with existing. What we will do is that once that we update this mesh library, is that our level doesn't get deleted, basically. So now let's grab this mesh and make it maybe 1.25. Okay, let's save these changes and go to scene, export as mesh library. I believe that we're using mesh library 2 right now, at least in my project. So let's just make sure that we are using the latest one, mesh library 2. So let's use that one. Once again, if you have problem exporting this mesh library, Godot goes mad and it doesn't allow you to export it. Just save it as a new file, so as mesh library 3 or whatever it is.
Let's make sure that this is ticked as well as this one. And mesh layer 2, overwrite it. Okay, there it is. And if we go to the main scene, nothing should have broken. The only thing that is a little bit weird is now the flag, okay, that is like offset a little bit. But it's because of the cell size, maybe here. Yes, because there isn't another explanation here of why this is not like aligned. But maybe this could be because it is offset directly on the, yes, I've moved the mesh and not the root node. That's why I always tell you, keep everything in 0, 0, because this happened. This object, the mesh library doesn't care about the position of the node, but yes, but it does care about the position of the mesh. So this mesh position must be 0, and if you want to move it just to see it, make sure that you are on the parent node. Okay, there it is. Now we believe that we still have to, yes, we still have to export this again. So let's go to the mesh library, scene, mesh library 2. Okay, there we go. And now there we have them completely aligned. I will just replace it with the flag in the correct direction. So let me delete this one and let me paint another one. But I don't know why it's painting it in the incorrect direction, but if not, let's try to rotate it. Okay, so over there. Well, it's working pretty weirdly. Okay, there it is. As you can see, I am painting in this direction and Godot is painting it in the other. But in reality, why I think it's happening is because the rotation of the grid map. This is the only thing that comes to my mind, to be completely honest. Well, most of these meshes are symmetrical, so you can also do the same thing for the barrels if you wanted to add decorations or these things or whatever. But well, anyway, let me delete this barrel also. There we go. Oh, I just did Control Z to delete all those. And yes, with this is done. Okay, and I'm gonna see you in the next one.